people, no problem, we'll continue, no problem. Okay, so we continue the live trading session. Okay,
Okay,
then
okay,
we can
okay.
do it. So first of all, only one people will join, so that's why I will get it. But in this time, we will continue our class. Okay, so let's
Okay,
go.
no problem. No
We
problem.
continue our class. Okay, so basically today is our third number of class, and mainly today I will try to discuss about that this topic, mainly calculating any indices from satellite images, freelancer or sentinel image, how we can easily calculate for the different types of satellite imagery, and how we can easily filtering and displaying the satellite images, mainly Sentinel-2, and monitor the NDWI or NDVI, how we can easily use the thresholding to extract the water body from this satellite imagery, and how we can easily make the time series chart, mainly NDVI, NDWI, or SAVI. These type of things, how you can easily calculate the time series chart, as well as how to export any shapefile from Google Earth Engine, how to add the gradient, legend, and title on Google Earth Engine, and then NDWI calculate from MODIS and satellite Landsat data. Okay, so let's go one by one, try to complete all of those things. So let me open my slide. So first of all, filtering and visualizing satellite images in Google Earth Engine. So previous class we talked about that Landsat imagery, how we can easily filtering and visualizing using Google Earth Engine. So today's session I will try to discuss about that suppose Sentinel-2 satellite imagery, how we can easily filtering and visualizing. So in this time we will also use the same filtering approach. First of all, we try to filter using our region of interest. Suppose I need the satellite image for Sentinel-2 in Dhaka city, and then we filter the specific image metadata. Suppose I need only for this image, which image will be not more than 1% cloud cover, as well as we also filtering this image for a specific time period. It can be rainy season, or it can be summer season, or any time period. Okay, so let's go. This time I talked about the Sentinel-2 satellite imagery. So first of all, I simply open my data catalog. So simply click on here, and here you can see about the Sentinel. Just click on the Sentinel, and you can see Sentinel-2 multi-spectral instrument. Click on here, and further try to open the surface reflectance or top of atmospheric. I simply open the top atmospheric. So here I can get all of those information about this image, availability, time period, dataset provider, Earth Engine, Synapse. So all of those things I can get from here, and I can see all of those band about that. So now from here, I simply copy this snippet, Earth Engine snippet, and paste in my code editor. Then I just give a name as a variable name. You can put any variable name. Suppose I put the name is that Sentinel-2. Okay. So now this is my image collection. This image collection is stored in this variable Sentinel-2. So now this image collection I want to filter, suppose two time period, summer season and rainy season. So for doing these things, first of all, I simply import my region of interest, ROI, suppose Dhaka city. So it imported, it shows as a table, default name. I want to change it, and I put the name as a RY, main region of interest. So now this image collection, Sentinel-2, I want to filter according to my region of interest, as well as according to my time period, suppose summer season and rainy season. For doing these things, first of all, I take a variable. Suppose I put the variable name is that any name. Suppose I put the name is that image wet season or rainy season or dry season. I put the image dry season. You can put any name. And then I call my Sentinel-2 image collection and paste here. First of all, we have to use the filter bounds function. filter bounds function intersecting our image with our specific region of interest RY. So basically this is the central two. It's my whole image collection. This whole image collection I just intersecting for my specific region of interest using filter bounds function, and then put my function shapefile variable name. Capacity mainly stored in this RY, so just I put here the RY. After that, suppose I just put here the filter date function and put my specific summer season or dry season time. Suppose I want to year of 2020 summer season. Okay, so for Bangladesh time. So just I put here 2020. Suppose start from 1st January from 2020. Suppose April post 30. Okay, I put this type of time period and then put here the filter metadata and I put here the name, operator and value. Suppose I put here the name, mainly it's a image properties name. I can easily get it from image properties. Suppose I choose the cloud pixel percentage. Operator set here the operator suppose less than, and value I set the value for 1. Okay, so I choose the less than 1 cloud pixel percentage. And further, if you want to check how many images I want to get from here, suppose print image dry and use at the size function. So now it's computing how many image collection is available. So here I can got this image collection is the 20 image collection. Okay, less than 1% cloud cover. So in this time we are using the filter metadata function. If you want, you can also use the other function instead of the filter metadata function. It's called the short function. Suppose I simply use here the short function. Short function is also used to filtering the image metadata. Okay, sorting. So in this time, I want to shorting my image collection using the cloud pixel percentage. So just I simply copy this image properties name and paste here. And now I want to check how many images I have to get. So I simply click to the run. In this time, we can get the 48 image collection. When I put here the short function, then I can get the image collection is the 48. And how I can sorting? I sorting using the cloud pixel percentage. And here I get that when I put the filter metadata, suppose when I put here the filter metadata, so just I simply click to the run, you can see how many images I can got. I can get 20 images. So in this time, when I use the short function, then my image collection is increased. I can get the 48 image collection. And when image collection is increased, then I can get the better composite. So in this time, I just simply use the another operator. It's called the false or boolean operator. So when I put here the false, then it remove all of those cloudy pixel. Okay, from 48 image collection, remove all of those cloudy pixel. And now I want to use here the mosaic function, mosaic, and then clip with my study area, which is RY. And now I want to just show the layer. Suppose just use here map.add layer and call the image right. So now click to the run and also center focus. So center focus of this boundary shape file and click to the run. So in this time, it create the composite from 48 images. So I can get look like that without visualization. So in this time, I have to set the visualization about that. So click on here. Suppose I set at that before red, green, and also put at that blue and custom 98% spacing. So now I can get this type of range 836 to 1766. So in this time, I want to reproject this band pixel value. So for that, they are already provide some scale. You can see in the bands that provides the scale value 0.01. Okay, so all of band have the same scale. So just I simply multiply this scale value, then we can get the proper scale friends. So just after mosaicing, just flip, just multiply. So multiply with our this value. So now try to check again. So now try to add the visualization. So in this term here, you can see you can get the proper range about that. So I set at the red, green, and also put at the blue. And then put at the stressing 98% and apply. Okay, so we can get this type of satellite imagery. And further, this visualization I want to import in my code editor. So further, simply click on the import, and you can see a new variable added in here, image is param. Just I simply copy this variable and paste after the object name. So this is my object. I simply paste here and then give the name, suppose image try. So now we can get the image. Okay. So in this time we talk about a new function. It's called the short function. If you want, you can also use here the short function instead of the filter metadata. Okay. And when you want to use the short function, then you have to use a Boolean operator false. Mainly in this time we are using the false. It remove all of those unnecessary cloudy pixel, and further it create the image collection. In this time when I use here the short function, then I can got the 48 image collection, and using the 48 image collection I just use the mosaic. And what is the mosaic? You can see I simply copy this function and open in the docs tab, then I can get the details information about the mosaic. You can see mosaic. So basically this function composite all the images in a collection using max. So all the image collection, mainly in this time here where we find out the total 48 image collection. So composite all the images in a collection using the max, and then create this composite. And further multiply this value because it's our band scale value. We simply put this value, then we can get the proper range about that, and then clip with our study area. Further we display this image. In this time we can get the very clean image. You can see there is no cloud about the satellite images. We can get very clean images. Okay, so now I want to need the image for suppose rainy season. For doing these things I use the same code. I simply copy from here and then paste. I simply suppose I change the variable name. It's the image, suppose wet season or wet, and then sentinel to filter bounds with my study area. I put the time period, suppose year of 2005 or 2020 05 to October. Okay, suppose I put this time period, and I use the same way. Okay, simply copy the image wet and paste. And further I want to add the letter, so just click to the run. So we can get this type of result. Just I simply click on here. Okay, I simply click on here and then add the band combination, suppose red, green, and blue. Custom stressing at 98%, and further apply it. and also import these things. So just simply copy and paste, and also change the layer name. Suppose it's the image wait season. So click to the run. So now we can get the 2 time period image. Okay. So here you can see in the rainy season image, we find out some cloudy pixel. This type of cloud, we can find out what the rainy pixel, rainy season imagery. Okay. So this type of imagery, this type of cloud, we are also removed from the Google Earth engine. Okay. So for the next class, I'll try to show you that how we can easily remove this type of cloud and haze. So in this time, we can get here the 2 time period image. One is the dry season. It's very clear. Okay. And another is the, you can see about that rainy season. We can get this type of cloud. Okay. So now in this time, I want to use these 2 images, and further I want to calculate it that water body. Okay, suppose how much water body is increasing in the rainy season. We also calculate the area. So for doing these things, first of all, we calculate the NDWI using this satellite imagery, mainly rainy season and dry season image I want to use, and further I want to calculate it that their water body. Okay, how much water is available for that. So let's go try to talk about the NDWI. I want to apply this formula on my satellite images and calculate the normalized difference water index. So in this time we are using the NDWI. So basically it's the green band minus near infrared band divided by green band plus near infrared band. Okay. So in this time I just use this formula, green minus near infrared divided by green plus near infrared, and then calculate the NDWI from rainy season and wet season and dry season imagery. So let's go try to discuss about that. So for that, there's a lot of way to calculate this type of equation. For that, I also try to discuss more. So in this time, we are using the one function, this function called that normalized difference function. Okay. So you can see about the normalized difference function. I simply explain about that. Simply search here normalized. You can see normalized difference function. So it's a normalized difference function. Compute the normalized difference between 2 bands. When you want to calculate any equation, have a 2 band, then we have to use this normalized difference function. And it computed as first minus second divided by first plus second. So in this time we are using this function. This function automatically computed first minus second divided by first plus second. Okay. So here you can see the mainly first band is the green minus near infrared divided by green plus near infrared. So when I put this band, it automatically calculated this type of equation. Mainly this function automatically calculated this type of equation. So let's go, we try to apply this function. For that I simply take a variable suppose NDWI for suppose dry, and I want to calculate the NDWI from the dry image. Okay, so I simply call the dry season image. So this is my dry season image variable. This variable is stored the dry season image, and then paste here and use a function. It's called the normalized difference, and I put the band name green and near infrared. So here you can see what is the green band. Green band mainly B3, and near infrared is the B8. So just I put here the B3 and B8. So put here the B3 and B8. When I put here the B3 and B8, it computed as B3 minus B8 divided by B3 plus B8 because I use here the normalized difference function. This normalized difference function mainly help you to calculate it the B3 minus B8 divided by B3 plus B8, mainly green minus near infrared divided by green plus near infrared. So this is the one kind of a normalized difference function to calculate this type of index. So basically this function only use for the two band. Okay, suppose you want to calculate any equation, this equation have only two band, then you can easily use this normalized difference function. You can see it compute the normalized difference between two band. So it has some limitation. It can be calculated only for the two band, but when you want to work for the more than two band, such as EVI or SAVI, so this type of index have a more than two band and also some constant value. So for that, this normalized difference function cannot be calculated. It can be calculated only for the two bands. Okay, then we can put the band name, band 1 and band 2, then it automatically calculated. Okay, so now display this result. So user map dot add layer and call the variable name NDWI dry. So now it shows the result in here. It should look like that. We also try to add the color. Then it show the grayscale color. You can see we can get the grayscale color in NDWI map. So I want to add the color. Suppose I just make a dictionary and put here the mean value. Suppose I put the mean value, suppose -1, and max value suppose +1, and put the plated color plated, suppose red, then suppose yellow, then put here the suppose green, and I need to show the high value for blue for water. Okay. And now for the click to run. We get this type of map of NDWI. Okay, so what's the function to include for calculation large area with more pixel? Okay, so basically what you want to use using this function, calculation, mainly different types of calculation you want to calculate. Mainly we are using the max pixel function. Okay, suppose when you face any problem, it cannot be calculated or cannot be exported, then for the big area we have to use at the max pixel. Okay, further to talk about that max pixel function, it also come when you want to it cannot be calculated, mainly statistical. Suppose you want to calculate it that average NDWI for this whole area. It's a small area, but we can easily get the result. But sometime when you want to work with for the big region, then it not be calculated. It show that there are a lot of pixel value, so that's why it cannot be calculated. So for that region, we have to use here the max pixel function. Okay, so now let's check about the another NDWI for rainy season or image weight. So just I take a variable, suppose NDWI weight, and then I call the weight season image. So basically you can see this is our weight season image. This I already created in here. I use it and then further paste here and use the function normalize difference between two things. One is the B3 green and infrared. And also show the layer about that. I simply copy this code and use it and copy this variable name paste here. Also change about the I put the layer name also. Suppose this layer I put the NDWI for dry season and also put the another layer name. So it's the NDWI rainy season. So now it also loaded the another map. So we can get this type of result. In this time, we can get this type of visualization. Okay, but if you want, you can also use the stressing and then find out get the better result. Suppose I just click on here and I want to just stressing, then we also get the more better looking map. In this time, it's the default. When I put it the -1, +1, it show the -1 and +1 custom. So when I just put the stressing 98%, it automatically show you that this type of things. You can see you can get the 0.3. And suppose I want to use the another layer and check about the what we can in this time we can get this type of things. Okay, so when I put here this stressing it, then I can easily find out the water body. This type of things is the water body. We can easily find out. After stressing, we can get the better visualization. So mainly we are using the stressing to find out the better visualization. In this time, you can this map is more realistic. You can get this type of water body as the blue color. Where there is no water, it shows this type of red color. Okay, medium we can get the yellow color. Okay, so this one we can get from here. So in this time, I just increasing this. Suppose I put here that 0.5. Also put here the suppose 0.5 stressing, and now click the run. So here you can see you can get this type of map. One is that rainy season NDWI and dry season NDWI. So it's the rainy season NDWI and it show about the dry season NDWI. So here you can see the difference between the two map for the rainy season and dry season. So mainly rainy season, we find out the water is the increasing. You can see in the rainy season, this type of water area is increasing. And dry season, you can get the very limited water body. You can see the difference between the two things. So now I want to calculate it how much water body is the increasing in the rainy season. Rainy season water, how much water body is the increasing, And now I want to apply the thresholding technique. So I want to put a thresholding, mainly a specific range of NDWI pixel range, and then I want to extract the water pixel for the rainy season, and how much water will be increasing. I want to find out it, and also calculated the area. So basically, this concept is also used for flood mapping. Suppose you want to create a composite for that before flood and after flood condition, and further you want to use the thresholding technique and then extract the flood area or flood region. So in this time, we are just use the same concept using the thresholding technique, and further we are just starting that water pixel, how much water body increasing, and also calculate the area. So basically, this is the difference between the two map. So in this time, how I can define the thresholding value? So basically, it's depend on your region. So now I want to check some value from an inspector tab. Suppose I click on here, and I just click on any water body. So you can say what's the value you can get from here. So here I find out this region. You can see here NDWI dry season. Okay, dry season, we find out that negative 0.4. Okay, for NDWI negative values indicating there is no water. Okay, so basically NDWI all of positive value indicating the water body. Okay, so for this location, basically you can see this type, this location, this coordinate, we find out in the dry season there is no water. In the dry season there is no water because it shows the negative pixel. Negative pixel for NDWI, it's indicating there is no water body. But you can see rainy season, you can find out the water body 0.35 NDWI value. We can check also check the other place. Suppose I want to check from here. Suppose click on here. So you can see the result. You can see here also same. In the NDWI dry season, there is no water body because I find out the pixel value is the negative. NDWI pixel value negative, it's indicating there is no water body. But when I put the NDWI value positive, it's indicating it must be water. Okay, so you can see the same location, same coordinate. We find out in the dry season there is no water. In the rainy season, I find out the water. You also can check about that. Suppose click on here. So here we find out the result. You can see in this time we find out the very small water body. Okay, in the dry season and rainy season, it also increasing. You can see 0.2, and we can get the dry season 0.03. So very low value about that. Also check some permanent water body. Suppose it's a permanent water body. Suppose I click on here, or also you can check something. In this time you can get, suppose it's a permanent water body. So just I click on here, then check about that pixel value. So you can see 0.1. Okay, it's the dry season, very low value, and we can get the rainy season. It show the result 0.2. Okay, so now I want to make a decision from here. Suppose I want to choose all of those value from rainy season greater than 0.2. Suppose it's a permanent water body. Okay, so first of all you have to choose a permanent water body. Suppose before flood and after flood you have to find out a one place where have always water. Okay, so it's called the permanent water body. So here I find out the permanent water body for the rainy season 0.2. We find out the 0.2. So less than 0.2 cannot be rainy season water. Okay, so in this time I choose all of those NDWI rainy season greater than 0.2. I consider as a water body greater than 0.2. All of those rainy season greater than 0.2 and less than 0.2 from dry season. So now write my thresholding value. Suppose I just take a variable. I put the variable name, suppose weight is on water, and I call the NDWI weight I consider all of those pixel greater than 0.2 and NDWI dry season less than 0.2. I consider it's a rainy season water or wet season water, because here you can see I find out for the permanent water body it show the 0.2. Okay, 0.2 is the rainy season, it show the 0.2. So I consider rainy season water or flood season or flood period water greater than 0.2, because it show the permanent water body show the 0.2. So I consider all of those rainy season water it will be greater than 0.2 and less than from dry season 0.2. I consider it's a wet season water. So it's very important about that, because it's not a fixed. So for the different region, it can be changed. So first of all, you have to check your permanent water body. Suppose any flood, when you want to make the flood mapping using the thresholding, first of all, you have to check about your permanent water body, what's the value we can get. Okay, so you choose greater than from here. So in this time I check here the permanent water body, you can find out the rainy season NDWI 0.2. So I consider it greater than 0.2, all of those pixel, and all of those pixel less than 0.2. So here you can say I can get that 0.1. So it's less than 0.2, must be 0.2 less than. So just I put here the less than 0.2, and using this condition I make a thresholding, and I want to all of those pixel I want to store it in this variable wet season water. So now let's check, add a layer about the wet season water. For doing these things, just I take a variable, I put the variable name, suppose water max, and call the wet season water, and then use a function update max with this condition. Simply copy this variable and paste here. Okay, and now further I want to show this result. So just use here map dot add layer and water max. I simply copy and paste here, and use here the plated function. I want to add the plated and put the plated color. Suppose water body show the blue color. Okay, so all of those pixel I want to show as a blue color. Okay, so click to the running this time. Okay, so now here you can see this type of map using this condition NWI weight greater than 0.2 and NWI dry season less than 0.2. We find out this type of water. So mainly this type of water we find out in the wet season or rainy season using this thresholding technique. NWI weight greater than 0.2. Basically in this time all of those water body NDWI is the greater than 0.2. If you want to check it, suppose I just click on here, you can check the result. Suppose this result we find out the greater than 0.2. Suppose you can check, we can get the 0.3. Okay, and we can find out the dry season less than 0.2. We can see we can get the negative 0.4. So it must be less than 0.2. So all of the pixel of water we find out. Suppose click on here, we can get that 0.24. So must be greater than 0.2, and also you can get that a negative 0.3. So it must be less than 0.2. Okay, so now we can find out this type of wet season water. So now further, suppose I want to calculate how much water body we find out in the wet season from here. So in this time, this is the another map. I simply put this layer name. Suppose it's the water body for rainy season. So basically, this is the process. We apply the thresholding. Okay. So using the thresholding, we can do there are a lot of analysis for the different in the remote sensing. So now I have to calculate the area. So how much water area we find out. For calculating this area, first of all, we have to. It's a raster. Okay. So basically, it's a raster format. This type of water body shows a raster format. So for that, first of all, I just simply search here. Suppose ee dot image dot pixel area. So basically, this is the function when you want to calculate any kind of raster area or pixel area, then we have to use the ee dot image dot pixel area, this function all time. Okay, for calculating the raster imagery area or pixel area. And basically, this you can get the result in square meter. We can get the result in square meter unit. Okay, further we can easily convert into square kilometer or hectare, no problem. Okay, so in this time we are use here this function e dot image dot pixel area. So just I simply copy this function and then take a variable name. I put the variable name suppose I put the variable name suppose area water. You can put any name. I put the suppose area water, and I call this watermarks because this watermarks is stored this map. Here you can see. I just simply open this map. Okay, this map, this water body map is stored in this variable watermarks. So just I simply put here the watermarks. Water marks it multiply with the function of